Hardware or software kits to test or improve SLAM-based application is a frequent request from research institutes, universities, and companies with a developed R&D department. JEXEL is now offering this option with the new HERON ROS converter, a tool that allows to use HERON as an efficient capture device with a full compatibility to the open-source ROS software developing kit for robotic applications. The HERON ROS converter generates an output bag file from the HERON RAW acquisitions, opening the possibility to customize, develop and test your SLAM approaches starting from the synchronized and calibrated sensors. After performing the HERON RAW data conversion to a ROS bag file, you can play the bag file and use the RQT tool to monitor the ROS topics that have been broadcasted. To the left, you can see the two Velodyne topics. Polar version to Cartesian coordinates has been performed, and here you can see the 6 available fields for every individual point. The 3 Cartesian coordinates, the intensity, the ring number, and the individual timestamp for every point. Regarding the inertial data, you can get angular velocity and linear acceleration, both referred to the XYZ axis, and also an orientation value which is given in quaternions. Regarding the image stream, it's a stream of JPEG images being broadcasted at 15 Hz. Here on the top right, you can get a sense of the frequency of every sensor. As I said, the images has been broadcasted at 15 Hz. The Velodyne performs a full rotation at 1/10 of a second, and the frequency of the IMU is much higher, around 400 Hz. On the bottom right, here, you can see the TF3 of all system. There is a base frame which represents the walking direction, then the main Velodyne, and attached to it the inertial sensor, the camera, and the secondary Velodyne. After the conversion in ROS bag file, you can visualize the file being broadcasted using the RVS tool from ROS. A HERON twin head is displayed, all TF3 with the IMU and the button. At the bottom, the horizontal Velodyne, the oblique one, and on top of them the camera. On the left, you can see in the topics 2 broadcasted point cloud, 1 per Velodyne. Expanding, you can see 6 available channels for every point, intensity, ring number, time, and the 3 Cartesian coordinates. Regarding the time, we can visualize it properly in this way. Setting a top ortho view, you can see that inside a full rotation the timestamp from points is 0, and it increases monotonically until it's complete the full rotation. All details regarding the usage of the converter, the data format, and all required parameters are explained in a specific documentation provided with the ROS converter. HERON system is also provided with a suite of software to create a final trajectory with full control of the SLAM parameters. After the data capture, HERON desktop that we can see here allows creating the trajectory, defining preset for several survey conditions. The global optimization process includes the possibility to insert coordinate constraint using ground control points, terrestrial laser scanner, or generic georeference point clouds. The HERON software suite covers the entire workflow up to the data analysis, visualization, and then export in open formats. Thanks to its versatility, HERON can be adopted in several applications, from multi-floor building to urban map, scan to bin, underground tunnel or cavities, forestry, or stockpile volume calculation. HERON can work integrating multiple sensors using drone data, traditional mobile data from car, or terrestrial laser scanner. As you can see here in this application, where drone data are aligned and overlapped with HERON mobile data. Last but not least, HERON is working not only as a mapping tool, but also as a localization and change detection system. Given a point cloud or a beam model of an area, you can survey it in time, localizing HERON with respect to the reference model and detecting the possible changes occurred in time. Please contact us at sales@jexel.it.